Alright, welcome back ladies and gentlemen. So in this video I'm gonna go over the ball connection. To explain what that is, let's look at this. Well, it's essentially a joystick connection and you can use it to have something behave like a joystick. And if you remember from your childhood days where you ever uh, used the arcade machine before with the joystick where you played Super Mario or something. I was a Tekken guy, but whatever you played, if you remember, using a joystick, that's essentially how it's gonna behave. So let's mess around with it. Let's see what happens. I'm gonna say assemble. I'm gonna bring out this part. Um, so if we go into the placement again, we're gonna see when we select ball, it's asking us for point of alignment. So a ball connection works slightly differently than slider and the pin connection stuff. It's asking us a point through which it's allowed to behave like a joystick. And if you think about how a joystick works, it's rotating about a point and it's moving around about a point. So it's kind of intuitive in that sense. And I haven't really made a point actively like a datum point myself, so I'm just gonna select a vertex or an intersection from this part, and then I'm gonna select just a tangent vertex like this one right here from this part. So right now this is technically enough if my ball connection was something that would not have any limitations and it's allowed to just move in any direction. So to properly just explain the difference that it's gonna make once I go further is, so watch right this. If I go just up, forward and backwards, it's allowed to rotate. When I go sideways, it's allowed to rotate. When I go diagonally, so I can go in any direction right now, and it's gonna allow me to rotate. But then there's something called a cone of axes, and with this I can limit this. So for this, it's asking me for a zero reference, zero motion axis for the part. So I'm gonna just zoom in and I'm gonna select a point. And this again, you can make a point yourself, a datum point, right here, a datum point, or you can just select something that's that's already like a built-in tangent point or something. So I've selected a tangent point right here, and I'm gonna select a tangent point with this, and then it's gonna show me the arc right there. So it's visibly showing me the arc, the cone, the axes. This is the visible, the graphical representation of where it's not allowed to move. So if I just bring it up to this point and I hit OK, and let's see what happens. So right now I'm not allowed to go any further than this right here. Let me make that clearer, I guess. So if we go top, right here, it's stopping. It's stopping at this point, and the reason I know it's stopping is right now because if I rotate this way, it should be flat straight, and it's not. So I'm trying to drag it, and it's kind of knocking against something. And I guess to make that more obvious, let me just make that cone a little bigger. Let's see, right here. So I'm just gonna click and drag. Oh, that's the part. I'm gonna click and drag, and I'm gonna bring the cone right here. And as you can see, it's moving the part itself too. So I'm limiting now even a bigger area. So this is the inside, and I'm moving the inside and making it smaller. So this should make it more obvious right here. Okay. So I guess to understand how this works properly is you have to keep in mind the point that you use as the cone of axes. So I use this point right here and just try to keep an eye on this corner. Um, that's the point I use, right? Yep, that's the point I use. So this is the point that's not gonna go beyond this cone of axes. So let's keep an eye on that. So watch. Right here, it's one end is attached to the vertex that I selected, and the other is it's getting stuck right now, and you can probably notice it's behaving a lot more strangely than it did before this cone of axis business. It's kind of weird that I use these parts right here to try to explain. I probably should have just modeled um, a joystick. That would have been easier, but it's I guess I should go back into the cone of axes, and I'm just gonna try to just, it might sound redundant, but I'm gonna just say the inside of this, or I guess the side of the cone that's represented by this right here, that's the side that that you're allowed to move in towards. So right now there's a larger area, larger than 180 degrees, where I'm allowed to move in either direction, and now it's less than 180. So I hope that's becoming clear what the purpose of this is. So that's what the use of a ball connection is to model something like oh, that's zero. That's, we don't want that. To model something like a joystick or something, but that's yeah, that's it. That's ball connection. Let me look at some other stuff now. Let me get rid of this. Get rid of that. Let me just bring the part in again. And if you don't understand this, you can leave a comment. I'll probably I can make a better video, but I think I'm being clear. Let's see. If not verbally, I hope I'm being clear in demonstration wise. Planar connection. This is. I'm not gonna show this. I'll just show this. Why not? Let me just activate the planes. And as the name states, it's gonna limit the movement based on planes. So I'm gonna select this plane right here. Then I'm gonna select this plane right here. Then I'm gonna select one more plane just to have a nice. Oh, hold on a second. Let me select. Let me get rid of this. So I'm gonna select those two planes again. Translation axes, and I'm gonna select two more planes. Let's say 50. Okay. Let me select 0 again. Okay, so it's allowed to move in the two planes that I've selected. So right here, it's not going in that direction, but it's going side to side. Let me do front. Let me do top. It's going side to side right here, and it's going upwards and downwards. So those were the two directional planes that we selected in this constraints. It's pretty straightforward. You select the constraints, and we're not really limiting any rotation here, so it's not constrained with that in any way. It's only constrained by the two planes that we selected. So it can go really anywhere in essentially like an XY graph type of way, but that's that. It's a pretty straightforward connection, and as I said before, I'm not going to try to explain all of these. You've seen how some of these work in the previous constraints. Mess around with it, and you should be able to figure this out. That's the best way to learn Creo, to just get stuck with something and spend at least 6 hours and then figure it out, and then you'll never forget it. But let's see. Yeah, that's it. That's the planar connection. And let me go over. Do I want to do the slot connection right now? Let's see what else we can go with. I'll just go with the slot connection. So slot connection is very useful, and it's one of my favorite connections. It's weird to say it's one of my favorites. I am that much of a nerd. I have a favorite connection in a software. Okay, so it's essentially something that gives you a lot of freedom when it comes to doing machine design, like mechanisms that have linkages, cams, and fun stuff like that. I'm probably saying a lot. That's a terrible habit I have. I'm sorry, but yeah. Okay, so let's go into the slot connection. But for a slot connection, I already know this, but let me just go into this and try to make a slot connection and fail, because I already know I will. So you select the slot connection. It's asking us for a point on a line, and we haven't really made a point on anything yet, and we don't really have a line yet. So here's what we're gonna do. We're gonna draw a point and a line. And as I'm doing this, I guess I'll explain what a slot connection is. Slot connection requires a point on the part and then a line on the main assembly. And then you can connect that point to that line, and it's only gonna move throughout that line, and it's gonna stop at the end of that line. So let me just sketch a line here on this. I'm gonna sketch it. Do this, and you can sketch things in assembly, by the way, but let me just do this. I'm gonna do a big line just to kind of hit the point home, and you can see it too in the environment. When I disable this is the line right here, and let me open up this part. Let me see if I actually made a point. I did make a point. Okay, so the way you would make a point is, you can open things up in an assembly environment. Right click open, and it opens up a window that's a separate window of its own. It's like a part modeling window, like a parametric window. It is actually a parametric window. And you can make a point here, you can save it and make changes accordingly, and they're going to be reflected upon the part that you have open in the assembly. So any changes you make when you open right here, you right click and open, and you make changes and you save it, they're gonna be made automatically here. You just gotta hit the refresh button right here. Refresh or regenerate. This is your lifesaver. Definitely hit this at least 2 or 3 times every 10 minutes. Maybe not every 10 minutes, I don't know, but definitely just hit regenerate. It's good to do that. So let's do a slot connection. Nope, that's not what I want. Edit definition, slot. Delete, slot. Okay, so now it's asking me for a point, and where did my point go? I disabled it, didn't I? Yep. So I'm gonna select that point. Okay, so this is a good example where I'm trying to select the point, but for some reason I keep selecting the edge. I'm gonna say only let me select data points. And look at that, I'm selecting the data point right here by right clicking it, and I'm gonna go back to all. Because we made a gigantic line and I can't see the sketch. What happened? Hold on a second. Oh, okay, I see what the problem was. Let me just open this up. Let me make a line. So the sketch or the line that you make should be within the part itself. So when you make a part, make the line on the part. Don't make the line in the assembly environment, because that's bad. And that's that. Let me just save that and get rid of this. Okay. So let me go back into this. Let's go into get rid of this slot connection. We're gonna select that point again and again. Datum point only for the selection. I'm gonna go back to all, and I'm gonna select this line. So this time the line stays there, and it's letting me select that line. And look at that. So let's see what actually happened. I just hit OK, and now when I click, I press down Control Alt, and then I click and drag. Look at this, it's only selected and it's only connected through that point. And let me just make that point visible. Oh, it is visible, it's just not showing up for some reason. Oh, it is, there we go. So, I don't know if you can see in this resolution, but there's a point there. You can believe me, but it's only connected through that point, and watch. It's gonna stop at the end of this line. Now, here's where the fun part comes in. You're not limited to just one point on a line, and you're not even limited to one line. So you can have another parallel line right here with another point on this part, and then you can have your part move in that path. And that's powerful when you're making linkages. I'm not gonna really make one right now, but if somebody already knows what this is and they just want to refresh what a slot connection is, I guess that's the point of this video. And just to introduce you to slot connections, it's a really powerful feature, and I have used it quite a lot in my projects, and it's fun. It's really fun, and the linkages that you can come up with once you use this tool, and the linkages you're capable of designing once you use this tool, they're just countless. and it's a good time. All right. So I think I've taught you enough about assemblies to start getting into kinematic and dynamic analyses. So I'm gonna just leave this as an end to the assembly videos. It was a really small series, and I'm probably gonna go into more advanced stuff for parts modeling and assemblies in general in a few more series. But this is supposed to be just an introduction, just to get you started. Uh, this is supposed to serve as a supplement to a first semester course in computer-aided engineering, and I hopefully it helps. But we're gonna get into analysis now, and I'll see you in those videos. That's it. How do I stop this?